Hi, Assalamualaikum. Welcome back to my channel, K615 KSSM. Today we continue Chapter 5, Electronics, on topic 5.2, Semiconductor Diodes. In this video, I will discuss two learning standards. The first one, describe the function of semiconductor diode. The second one, communicate about the function of semiconductor diode and capacitor as rectifier. In my previous video, I've discussed about what is diode. Diode is produced by combination of N-type and P-type semiconductor. That's why diode is also known as PN junction. In Chapter 4, you have learned about transmission of electrical power from the power station to the consumers through a national grid network in form of alternating current, AC current. However, in everyday life, many electrical devices can only function with direct current. As example, your handphone's battery, it is DC battery. Therefore, the alternating current has to be converted into direct current. If you want to charge the handphone's battery, you need to plug in into the main power supply, which is alternating current. So there must be a component that can convert alternating current to direct current in order to charge the handphone's battery. The electronic component that need to convert alternating current to direct current is semiconductor diode. In this case, diode function as a rectifier, means able to convert AC to DC, or we can say change AC to DC. Let's look at the structure of semiconductor diode. Diode in the shape of cylinder like this, it has two terminals. You can see there's a band here to differentiate between cathode and anode. The electrical symbol for diode is, you can see there are two terminals here. The big arrowhead here actually represent the P-type of semiconductor, and this one is N-type. Thus, for this big arrowhead, we can mark it as anode or positive terminal, and the N-type is marked as cathode or negative terminal. So whenever you draw diode symbol in electrical circuit, you can use this symbol. Now you can refer to activity 5.4. In this activity is to discuss the function of semiconductor diodes. Apparatus required for this activity are diode, dry cell, cell holder, bulb, and connecting wires. So we have two circuits here, circuit A and circuit B. For the first part, what we do, connect the diode in forward bias. What is the meaning of forward bias? That is, positive terminal of dry cell connected to anode and negative terminal connected to cathode. Observe what happens to the bulb and record your observation. So you can see here, this is anode for the diode, or we can say is positive terminal, and this is the cathode, which is negative. So in this case, you can see the positive terminal of diode is connected to positive terminal battery. Negative terminal of the diode is connected to negative terminal of battery. So this connection, we call it forward bias. In this forward bias, it will cause the voltage across the junction to be overcome, and current is allowed to flow in the circuit. Thus, the bulb lights up. So for forward bias, diode allow current to flow. What happens if the terminal of the battery is reversed? Meaning, the anode terminal of diode is connected to negative terminal of battery. The negative terminal of diode is connected to positive. So this connection, we call it reverse bias. When reverse bias, the voltage across the junction will be increased and cannot be overcome by battery. Thus, the circuit will be broken. There's no current flow in the circuit. The bulb does not light up. Okay, let's discuss some questions regarding this activity. What is the function of diode in this activity? Allow current to flow in one direction. State condition when diode allows current to pass through it. The bulb lights up. If the drive cell is changed to alternating current power supply, what will happen to the bulb? The bulb will continuously light up because the direction of current keep changing will produce the current to be flow when forward bias and then does not flow when reverse bias. Okay, let's look at more on the function of semiconductor diode. Semiconductor diode is electronic component which allow electric current to flow in one direction only. A semiconductor diode is formed by joining a p-type semiconductor and n-type semiconductor to form p-n junction. Now we want to explain the diode connections. The first one is forward bias. We want to discuss what exactly happens when the diode is forward bias. So this is diode p-n junction. You can see at the junction, this is depletion layer with certain value of junction voltage, or we also call it potential barrier. When the circuit is not completed, the value of voltage at the depletion layer will block the movement of electrons across the junction. Now what happens if the circuit is completed? There's a current flow from positive terminal of battery to negative terminal of battery. What happens to the voltage at the junction? So in this forward bias connection, you can see this is negative, and the n-type with a lot of electrons as majority charge carrier will experience repel force. Thus, electrons, which is in n-type, now able to cross over the junction. When the electron able to cross over the junction, depletion layer will become thinner, and the voltage at the junction will be overcome by the voltage of battery. So when this happens, the diode allow current to flow in the circuit, or we can say the bulb lights up. We can write the explanation as follows. When diode is forward biased, the holes will move towards the n-type semiconductor, while electron will move towards the p-type semiconductor. You can see electron will cross over the junction. Depletion layer becomes thinner. Junction voltage V across depletion layer decreases, and resistance of diode becomes smaller. For reverse bias, so you can see the p-type is connected to negative terminal, the n-type is connected to positive. Logically, electrons always attracted to positive. So electrons in the n-type will be attracted to flow to positive terminal of battery. Or we can say electrons move away from the junction. So when move away from the junction, the depletion layer will become thicker. Or we can say that the junction voltage increases. Even though the voltage of battery is quite high, it still cannot overcome the junction voltage. Thus, there's no charge carrier able to cross the junction now. Or we can say the circuit is broken. Diode does not allow current to flow in the circuit. So we can see the bulb does not light up. So can you see the difference or not between forward bias and reverse bias circuit? So you must be able to explain, okay, this situation when diode is forward bias circuit or reverse bias circuit. The use of semiconductor diode and capacitor in the rectification of alternating current. As we know that because of the diode allow current to flow in one direction, this diode can function as a rectifier. The process involved to convert AC to DC, we call it rectification. So for example here, you can see a smartphone is connected to AC power supply. Means there must be a component in the adapter here, or we call it diode, that able to convert AC to DC to charge the handphone's battery. So how does semiconductor diode convert AC to DC? So this one by using rectification process. So now let's discuss the process. Okay, so this is the process. Process of converting an alternating current to direct current, we call it rectification. There are two types of rectification, half-wave rectification and full-wave rectification. You can look at activity 5.5. This one is to build rectification circuit. So we have this rectification kit for half-wave rectification and full-wave rectification. The power supply, we call it an input, and the cathode ray will display the output. As you know that for input is alternating current, direction of alternating current keep changing every half cycle, positive, negative, and so on. If you look at the output here, the negative part is missing. So this one you can see direction of current is flowing in one direction. The output is DC. Our input is AC. Yeah? This is AC power supply, or input is AC. Output produce DC. As you can see, the current flow in one direction. But the negative part already missing. Means this circuit just convert half of the wave of alternating current. That's why we call it half-wave rectification. This is a rectification circuit for full-wave rectification. This is the input. This is the output. Look at the output here. You can see the negative part now changed to positive. Thus, it produced direct current. So all the waves of the AC input now is converted to DC. That's why we call it full wave rectification. Okay, let's discuss more by using a circuit. For half-wave rectification, a complete cycle of AC current consists of two half cycles, positive half cycle and negative half cycle. During the positive half cycle, diode is forward bias, thus allow current to flow through it. During the negative half cycle, semiconductor diode is reverse bias. The half cycle rectification process is called half-wave rectification. If you look at from the circuit, this is the input, the current from the power supply. This is AC power supply. Direction of current keep changing every half cycle. Let's say for the positive half cycle, the first positive half cycle, current is flowing from this point to this point. So we can mark here as A, for example, and this point is B. So for the first half positive, let's say the current is flowing from A to B. When current flowing from A to B, A function as a positive terminal, B function as negative terminal. Now you check the diode. This is positive, this is negative. So you can see the P-type connector positive, the N-type connector negative. So this one, we call it forward bias. When forward bias, current is allowed to flow. If the output part here is connected to CRO, CRO will display the waveform. You look at the negative part. This one is the first positive. Let's look at the first negative. This one. For the first negative, now direction is reverse. Current flowing in the reverse direction. So what happens to the terminal? Now the current is flowing from B to A. So when this happens, B will access positive terminal, A become negative. We check the diode, the P-type connector negative, the N-type connector positive. Thus, it becomes reverse bias. When reverse bias, the circuit will be broken. Diode does not allow current to flow through it. Thus, CRO cannot record anything. So it becomes zero current here. The negative part is missing. Then the process will continue. You can see the output is only half of the wave is rectified. Half of the AC current changed to DC. That's why we call it half wave rectification. Let's look at the full wave rectification. Arrangement of 4 diodes is called bridge rectifier. This arrangement allows a complete cycle of current to flow in the same direction through load R. You look at the circuit. For the input, direction of current keep changing every half cycle. So this is the first positive. This is the first negative. Let's look at the current flow in the first positive direction. We can put this one as A. And this point is B. For the first positive half cycle, current flow from A to B. We can mark the current like this. This is the current flowing. So when reach here, there are 2 diodes. When flow A to B, for the first positive, current flow from A to B, meaning A is positive, B is negative. If you check the diode, diode D4 is reverse bias. So the circuit broken here. Now the current continue to flow through D1. When reach here, D3 also reverse bias. So current cannot flow here. Circuit broken here. So continue to flow through R. When flow through R, this one connect to CRO, which can show the output. Thus, CRO will show the first half positive. Okay, then the current will continue to flow to here. You can see D4 is forward bias, but current cannot flow back to the same terminal. Thus, current will continue to flow through D2 and then complete the circuit to B. So we can write something like this. From A, go to D1. From D1, go to R. From R, go to D2. And then complete, go to B. Let's look at the negative half cycle, the negative part. This one. Okay, so for negative part, terminal A, terminal B. Now current is flowing from B to A, meaning now B is positive, A is negative. So the current is flowing from B, go to here. D2 is reverse bias, circuit broken here. So current will flow through D3 and reach here. Cannot go to D1 because reverse bias, and then go to R. The CRO will show the other half, which is negative, now rectified. Why in the same direction? Because if you check direction of current that flow through R, for the first positive and first negative is equal, same direction. That's why the current produced pass through R flowing in the same direction. Okay, so you can see the current continue to flow and reach here. It cannot go to D2 because cannot go back to the same terminal. Thus go through D4 and complete to E. If we can write the path of the current flowing from B go to D3 and then go to R and then go to D4 and then go to A. So you can see for the both positive and negative cycle of the input current, there is a current flow through R in the same direction. Thus the output will produce direct current. So in this case, there's no wave loss, or there's no current that lost. Okay, positive and negative all rectified. That's why we call it full wave rectification. Okay, full wave rectification is a process where both halves of every cycle of alternating current is made to flow in the same direction. Full wave rectification displayed on cathode ray oscilloscope screen is shown in figure. So you can see this is the output for full wave rectification, meaning the negative part is already rectified. Negative part already rectified. Okay, so it produces output like this. So this one we call it rectification process, where AC now change to DC. This one is DC because current is flowing in one direction only. If you look at the output for the full wave rectification, the magnitude of current is not steady. You can see the current increase to maximum and then decrease to 0, increase again, so the magnitude is not steady as compared to a dry cell. For dry cell, for example, this one, dry cell, you can see the current flow uniformly like this, or constant, means steady current. This is steady. Okay, so whenever we use this circuit to convert AC and DC, so it does not produce an output which is as good as a dry cell or DC power supply. So what we do for this circuit, how to make it the current to become steady, so that it will increase the efficiency of charging process, for example. So what we need for this activity is to use another component which can smooth out the output of the process of rectification. So that one we call it capacitor. Capacitor, the symbol is like this, two parallel plates. So in this case, capacitors is used in smoothing direct current. Half wave and full wave rectification produce DC, which is not smooth. Therefore, capacitor is used to smooth the current in rectification circuit. You can watch the video related. Okay. Let's look at how capacitor is used to smooth out the output current. For the half wave rectification, you can see the output is like this. This is the output for, you can see the dash line. That one is the output. It's not very good, not steady. You can see at certain point here, current suddenly becomes 0. Okay, so what the function of the capacitor here is to supply current whenever the current flow in the circuit drop. Or we can say, in this case, capacitor able to be charged and discharged. Let's look at how capacitor is charged and discharged. Let's say for the half-wave rectification, current flow from A to B. Diode is forward bias, meaning current is allowed to flow in the circuit. When current flow in the circuit, what capacitor do is to collect charge. This is A is positive terminal, so it will collect charge here. Okay, and then the current will continue to flow to R. Okay, and complete the circuit. When current increase, capacitor was to be charged, and then current maximum, it will be charged maximally here. Then what happens? When direction of current in the circuit is reversed, means the current is flowing from B to A for the second circuit. What happens to the diode? The diode will become reverse bias, meaning the circuit will be broken. When circuit is broken, meaning this part no longer function. What is left is this part. As you can see, this part, which is a small circuit, is a complete circuit. Just now, the capacitor is already fully charged. Thus, when no current flow in the circuit, the capacitor will act like a battery. Now, the current will be supplied by capacitor to R. Or we can say the capacitor discharge. So just now, when current dropped to 0 here, the capacitor discharge. Thus, there is a current flow. As you can see the blue line here, current is not 0 because current is supplied by capacitor. Okay, and then when the current reverse again, A to B, it will be charged again and then discharge. If you look at the output of the current produced, it is much better than the one without capacitor. It is more steady than without capacitor. So that's why in this case, capacitor is used to smooth out the output current of rectification process. The same thing happens for the full wave rectification. You can discuss by using the same method. Okay, so you can see when there's a current flow, capacitor will be charged. When the current starts to drop to 0 here, capacitor discharge. Charge, discharge. Charge, discharge. As you can see, the output will become which is better than without capacitor. So in this case, capacitor is used to smooth out the output current of rectification. Thus, if you want to charge the handphone, it will become more effective as compared to without capacitor. So you can read through the explanation here. Capacitor C is connected in parallel to the load R. When power supply is turned on, the output current becomes smooth. When potential difference increases, capacitor will be charged and energy is stored in capacitor. When potential difference decreases, capacitor will discharge so that the output current does not fall to 0. The energy stored in capacitor will maintain the potential difference across the resistor R. The smooth output waveform shows that capacitor is functioning as current smoother. So, or in other words, we can say capacitor allow AC to flow through it, but block DC. As you can see, when we use DC, it can be charged but cannot be discharged. Thus the circuit will be broken. But for AC, it can be charged and discharged. Thus we can say capacitor allow AC current to pass through to it.